The Vendorpedia platform is purpose-built to automate the third-party risk lifecycle with 3 core capabilities: assessments and due diligence, global risk exchange, and vendor chasing services.
Hello, and welcome to Privilege Escalation and Whitelisting Bypass with Proxy DLLs. If you're joining us live, our speaker is in the Slido discussion, answering your questions right now. For audio-video issues, click the technical support button below. I'd now like to turn it over to Jake Williams for the presentation.
Hey, thank you so much, Casey. I'm super excited to be here, and thanks to everybody for being out here with us at RSA. So I wanted to get in and start talking about, really from our agenda standpoint, what are we going to cover? Right off the bat here, I want to talk about what is a proxy DLL, because we're talking about privilege escalation and bypass. And I assume most people coming to this may know what a proxy DLL is. I assume some of you don't. I want to discuss why we're going to use proxy DLLs. Why has this become such an attractive thing for us to use? How do we build one? And then apply it, of course, right? Because, well, I mean, I don't want to talk at you. I'd rather tell you how to do something. And then we'll wrap it up with some closing thoughts, right? So what is a proxy DLL? A proxy DLL is a malicious DLL that exports the same function names as the legitimate DLL that it's impersonating. As proxy DLL is forwarding or proxying API calls from an application to the legitimate DLL. You can almost think about this, if you're familiar with the term hooking, right, or in some cases shimming. This is basically the equivalent of shimming a malicious DLL into a legitimate application, right? And this has tons of uses, but privilege escalation and whitelist bypass are 2 of the most important, and really they're the 2 that come into play the most for us when we're doing our assessment work at my consultancy, right? So the proxy DLL can go execute any malicious code. It could execute a callback. It could generate a bind shell. It could do any malicious payload here. The idea here, I'm not going to get into the payloads because you do that, right? Payloads are a dime a dozen. What we're really talking about here is how do I get the payload to execute on the target machine, right? Now, in the case of privilege escalation, you probably want to do something after the fact to maintain that privilege escalation, right? So why proxy DLLs in the first place, right? Well, first off, proxy DLL allows attackers to persist malicious code on a system. They don't have to go change auto runs. This is critical, right? When I got into the field here many moons ago, auto runs was like the kind of the go-to, right? You'd step back and be like, okay, hey, I'm going to go in and implement auto runs. It's like rock on, love it, right? So I'd be like, yeah, we'll run auto runs. And look, realistically, most people didn't understand what they were even looking at. But the reality today is, man, these EDR systems, endpoint detection response systems, are a dime a dozen. We're getting into threat hunting being a regular thing. You change auto runs on a system, right? You probably know about frequency of least occurrence, right? Looking across an enterprise and like, where are the standouts from the auto runs who start with a golden image, and that's probably the malware. It's probably your implant, your tool, right, as a red teamer or penetration tester sitting there. It's a deviation from the baseline. And so we don't want to add things to auto runs if we can avoid it. Now, look, defenders are getting way better at monitoring process lists, right? It used to be you could go throw some randomly named executable in a process list and game on. People were like, cool, it's good. Can't do that anymore. Application whitelisting. It's definitely changing the game on which programs can actually start. There's a lot of reasons that organizations, even the ones that implement good whitelisting, don't whitelist DLLs. I actually have a couple of customers that have tried. My friends, this is a religious experience. It is a absolutely painful experience to try to whitelist DLLs. And there's lots of reasons for this too. But one of the things that I'll throw out there is that because so few people, so few organizations whitelist DLLs, I will tell you that a number of major manufacturers and major software vendors, and I won't get into naming names here because that's not what it's all about, but a number of these software vendors periodically release new software where they forget to digitally sign the DLLs. And this creates all kinds of problems, right? Now not all the DLLs. It's like they can do an update, and it's like the executables, that gets checked off in QA, but the DLLs don't. Nobody notices it because so few people try to do this. Now, again, if you are whitelisting DLLs, now all of a sudden for saying only by digital signature, yeah, you can't do it by SHA, whether you're SHA-256, SHA-1, I don't even care what SHA you're using. Bottom line, you can't do it by that, right? Really what we end up with now is really going to digital certificates. And again, for lots of reasons, this is not a viable option for most organizations. So I want to talk about how do we use a proxy DLL. There's two main ways that we use it. Now, obviously, there's other ways that you can use proxy DLLs, but one is maintaining persistence. So this is a big deal for us, right? I just talked about the fact that I want to maintain persistence, but I also know that with persistence, I have the downside there, and I'm leaving something behind on the system. Persistence meaning, of course, I don't want to have to re-exploit the system again to get back and persist my payload. I know that there are going to be times if I change auto runs, I'm going to get caught, right? So that's a big one. So if I can, without changing the auto runs and without changing the program that's executing, every time we get back on this, every time that process restarts, get code into the context of that process, game on. Now, this really ramps it up a notch here. If we can find a program that executes in a privileged context, right? So a privileged context, meaning it's running as a system or a service account or administrator or whatever the case is. If we can then write a DLL to that directory where that executable runs from, right? That means that we can then go in and gain privilege escalation rather than just persistence, right? So now we're persisting as basically persisting as a privileged user from an unprivileged context. Now, before you step back and you're like, well, that's dumb, that never happens. First off, let me tell you, that definitely happens. It happens all the time. Major bank, whose name obviously I will not reveal for customer reasons, major bank in the United States, one of the very, very large ones that I'm positive everybody knows the name of, we were able to take over with system their golden image, every machine in their network. It was because we were able to go add a DLL to a directory. Now, we couldn't overwrite stuff in that directory, but adding files to a directory is a very common extended NTFS permission. Happens to be inherited as well in subdirectories. And so if it's set at a high-level directory, then as you install new software, they're game on, right? So we're all about this. So just something to keep in mind there as we roll. So talking about proxy DLLs, I have to, before we get further into this, I'm going to assume that you have some experience, right, with DLL sideloading or DLL search order hijacking, but in case you don't, right, want to quickly walk through the search order for DLLs. The Windows loader finds DLLs by name, but the path isn't specified. This is actually intentional. I suspect that if you could like roll back, right, 30 years in history and go back to Microsoft, maybe a little bit older than 30 years here, but go back and be like, hey, are you sure you want to do that? I think they're going to tell you no. I think they're going to be like, we probably should have taken and put the full path for the DLL. And now there are some benefits to not having the full path. I don't have time to get into some of the actual, some of the compatibility benefits and whatnot. But really what's happening here is when you import a DLL, the executable at load time, the loader goes in, parses the portable executable header, the PE header, and says, hey, what are we importing? And then it says, hey, let me go find that DLL. And it searches through these directories to find it in this order. You'll notice that the number one up there is the directory from which the DLL is loaded, from which the application is loaded. So if we can write a DLL to the same directory that the executable runs from, and again, most often this is entirely possible, game on, we win. Now, if you're thinking, let's say I compromised some Yahoo with a phishing email because he's like, heck yeah, I want to see confidential, whatever their executive compensation bonus.xls, and he opens it up, and then sure enough, it exploits them, and you're running as a regular user. What now, right? Well, are there auto runs with regulars? Yeah, you betcha, right? You think about like GoToMeeting and in many cases Dropbox, and you just run through like all these little applications that may not be installed in the golden image, but they run under that user context. These GoToMeetings and WebExes and you name it. It's very common that they install under the user's context, and they auto run in that user context as well, right? So meaning C users, whoever their name is. So game on, we can definitely write to there. Again, no privilege escalation with that, but we do get persistence consistently, and game on, we're happy with that. So next step, we need to pick the DLL to proxy. We have to find a DLL that's loaded by our target application. If it's not loaded by the target app, then that doesn't help me at all, right? I need to know one that is in the same folder, does not exist in the same folder as the target application. Now, even once I have admin permissions, I don't want to go poison something in System32 or Sysfile64 because odds are good that the actual legitimate DLL is sitting right there, and that doesn't help me. Right. And finally here, there's this special category of DLLs called known DLLs on the target system. Right. So we have to avoid it being in known DLLs as well. And what are known DLLs? Right. Well, they're known. Well, no joke, right? But what does that mean? What's happening here effectively is these are DLLs that are preloaded, meaning that before the loader, right, before the loader goes in and basically starts parsing the import address table, and well, as it parses the import address table, regardless, it looks and says, hey, I need to go load this DLL. Now, what's going to happen there is it's going to open the file. And as it opens the file, it's going to create a handle in the global object table. Turns out that that open only happens if the name of the DLL doesn't already appear in the global object table. Well, it turns out, or the object manager, as terms go, as it turns out here, these DLLs, even though they don't show up in your list of loaded modules automatically, it turns out that handles to the DLLs already exist. And so the problem that we run into here is that if we try and open one of those DLLs, it's never going to open our malicious DLL because there's an existing handle to it elsewhere. Now, the bad news is that there's no one solid list of known DLLs. They change depending on the operating system version. And there's a lot of reasons for this, and it gets deeply technical. INSCU and others have talked about this in some of the Windows internals books and some of the rationale behind this, and why don't they preload all the DLLs with the object manager. And look, bottom line, you just need to know for your target operating system what are known DLLs and what aren't, right? Ones to avoid, NTDLL, kernel32.dll, et cetera. Avoid those, right? Anything that's super common, right? Top 10, top 12, right? So WinSock, WinINet, typically those sit in known DLLs, right? And as a matter of fact, I think those particular ones always do. Bottom line, I want to pick something that's kind of obscure, but not like crazy obscure, right? Bottom line, it just can't be a known DLL. So if all that was super technical, just query your known DLLs key, look at it and be like, hey, is my DLL on that list? If no, proceed. That's it, right? So let's talk about how this actually works, right? So I got my proxy DLLs. Now in this case, we're only doing whitelist bypass, right? So I have a signed application. It's in cGoodApp. Now it turns out that in the root of your file system, by default, NTFS implements something or implements a special permission that's called basically add data add data and create files, right? So basically you can create a file that doesn't already exist in the basically in that particular folder. So when GoodApp installed, the MSI installer, right, basically said, okay, inherit the permissions of this directory, right? Set ownership, but it says for the permissions, inherit the permissions. Well, the root says add files, and so when it installed into GoodApp, cGoodApp received those same permissions. So we can write new files. We can't overwrite existing files in that directory because of ownership permissions. But if the file name doesn't yet exist in the directory, game on, we can go ahead and write that there. So what we do then is we go and we take a look at what this thing imports. Now, I've been super easy here to basically say, okay, well, let's only show a couple of DLLs. One of them is kernel32.dll, one of them is msimg.dll. All right, so let's walk through the loading process. And so what happens here is that GoodApp is going to go in and load kernel32.dll. Now, the search order here doesn't matter. If you recall, the search order only matters for things that aren't known DLLs. Kernel32 is always in known DLLs, and hence none of that matters, right? And so it's going to go grab it technically from System32, although again, technically it's grabbing it from the object manager, which already grabbed it from from System32. And so what ultimately happens there, of course, is that Kernel32 imports from NTDLL. And so we have, because Kernel32 imports from NTDLL, NTDLL also gets loaded, right? So we have an explicit load, which is Kernel32, and an implicit load, right? Implicit meaning that it was loaded by something else. It was explicitly loaded by the app. So the GoodApp next goes and loads msimg.dll, msimg32, excuse me, .dll. Now here, this is critical. We've now written a malicious DLL named msimg32.dll into our directory, cGoodApp. Now, game on, we're set here, right? So that means that our DLL is going to be loaded. But it's not enough to simply fire up Meterpreter and Metasploit and be like, generate me a DLL. You can't just do that and assume everything's going to work, because the Windows loader is going to be like, okay, cool, I loaded that DLL. Now let me resolve these exported functions, right? Because they're in the imported address table of GoodApp. And it can't do it because we haven't exported those functions, right? That's where the proxy comes into play. By the way, beyond just exporting those function names, they actually have to do something, right? The program needs it. And if you don't provide that code, the program is going to crash. Well, that's bad for you. you because you wanted to persist on the box. Also, lots of program crashes tend to get the help desk called, and we all know what the help desk is going to do, right? That they're literally going to nuke the machine from orbit. They're going to reinstall. They're probably not going to investigate. You're less likely to get caught here than you are simply to have that machine reinstalled. But either way, we lose. I don't want that, right? So my proxy DLL, what it's going to do is it's going to proxy any of those calls. It has to export all the same stuff, proxy those calls, and then I have to write a legitimate copy. Of MSIMG32.dll. Now, I'm going to name it something hopefully less suspicious here. I can't have a name collision, right? So what I'm going to have to do is this guy here, MSIMG32_.dll, is really the legitimate copy of that. The reason I can't just import it from System32 like would normally happen is I'm already taking up that name, right? And so it turns out that's going to cause a naming collision, and it's not going to work. And so no problem, though. I'm okay here, totally okay with, now again, you want to name this something like, don't say obviously not malware.dll, right? Make it something that blends in. One of the ones that I've actually tricked folks with consistently and even use this as a blue team challenge is I'll change the 32 to 64 and I'll ask people which one's illegitimate. And they're like, man, are we on a 64-bit system? It's probably a 32 one, right? It turns out the answer is no, it's really the 64. Bottom line, name it something, right, that's not going to get you caught. Right, that's what it comes down to, right? Very few people look at DLL lists in the first place, but if they do, you want something that's not going to jump right out at them. So we've talked about what a proxy DLL is. We've talked about how it gets loaded, right? We talked about what you can do with it. How do we actually build one of these things, right? Because that's really the takeaway, right? I mean, well, I could simply come in here and be like, proxy DLLs are awesome, and then leave you with like nothing. We don't do that, right? So let's talk about how we build this. You need a few tools. First off, you need a tool to read and dump the imports. I like Dumpbin for a couple of reasons. It is by far not my favorite PE editor for any number of reasons, but Dumpbin on Windows gets installed when, of course, we're talking about Windows here, DLLs, right? It's installed with Visual Studio. So it's a tool that I don't have to go out anyway to get because I'm using Visual Studio as my compiler. Right. So given that I'm using Visual Studio as my compiler, knowing that Dumpbin is already there, game on. Again, I don't use it for much beyond this. The reason I like Dumpbin for this specifically is that it dumps everything out in text, right? And that's really where I want it, because rather than me going into a GUI, right, and going through and copying individually and all that, no, right? So anything that I can use from a text standpoint, that makes it super easy to go in and start scripting some of these statements that I need to build. And then, of course, I need time and patience, right? Or some Python to help me build this out, or any scripting language for that matter. I don't have this process fully automated, but I'd say it's 85% automated, right? So as you get into building that proxy DLL, let's kind of step through what we do here, right? So my step one, first I need to use Dumpbin again, or any other tool that can read the exports, right? But what I'm doing here really is I'm getting away from the GUI and I'm going to the command line interface, right? I used to have a joke with people with CLI where I was like, hey, what does CLI stand for? And they'd be like, the command line interface. I'm like, no, it's the cache line interface, right? Because the people who know how to use it make a heck of a lot more cache than those that don't, right? And look, when it comes down to it here, this is going to help me dramatically. Now, technically, I don't need all of the exports. Technically, I only need to know the actual exports that are going to be called by my target application. Some people have come in and they're like, well, you could run Dumpbin and just look at the imports. And I'm like, I could. Here's where I've been burned by that in the past. Some, because of loading overhead, some programs at runtime, particularly in like little fringe conditions, the user clicks the help menu. Suddenly they then go dynamically resolve a bunch of other APIs. And now I'm toast, right? For me, as far as I'm concerned, I'm just like, look, I know that the legitimate MSIMG32.dll exports the following, whatever it is. I think it's 130 some odd functions on the version of Windows I looked at last, something along those lines. Whatever it is there, bottom line, instead of me going in and be like, here are the 5 this one application surgically import, I'm like, forget it. It's 130. I just export all of them. Right? My proxy DLL will export everything so it actually looks just like MSIMG30. This is future-proof me, right? The other one's super surgical, don't get me wrong. But from a security benefit, there's actual detection benefit. There's no benefit, as it turns out. You only hurt yourself, right? So don't do this. Bottom line, just do all the exports, right? Next thing I'm going to do here is I'm going to copy all these export names from the output. Really, I only want the name at the end of it, right? The ordinal and technically the ordinal helps. The ordinal, for those that don't know, is the basically the order in which these functions are exported from. And I said a lot, but I said 100 and some odd. Maybe that was WinMM. My apologies here. It looks like I've got 5 over here, but I won't swear that this is the same DLL. Bottom line, what we're doing here again is we're going to grab those there. And again, the name is what I'm looking at. It is a rare case that an application imports by ordinal. It's a fringe case. I'm not going to cover it here, but just Google ordinals and importing by ordinals and dive down that rabbit hole. You'll see that it's a very rare thing, except in Microsoft software. Microsoft software and a couple of antiviruses do this. You're probably not poisoning any of that, right? It's very likely third-party applications that you're doing this with. So next thing I'm going to do here is I need to create pragma statements for all of my imports. Remember I said before I do all of these. Now, you'll notice here that what I'm doing here is that my DLL name in this particular example is MSIMG32.dll, right? So I talked about the 64 thing. I love doubling up a letter because it is really tough to see this. It's tough. Now, this actually, it's hard-coded into my DLL, my proxy DLL. So I lose some flexibility on the target side, meaning that I can't dynamically change the name without recompiling. That's just part of the game, right? So just be aware of that as we go. And you'll see here that I'm telling the linker, basically go export this. That I've got an export and I want to make sure that I've got this named appropriately, and it's saying, hey, when this export gets called, basically then you want to go over and basically pass that off to MSIMMG32.dll. Right? Okay, so got that, and then all I'm going to do is take those pragma statements and copy those into a DLL project in Visual Studio. Now, if you're not familiar with coding in Visual Studio, and this is actually something that came up, as we were kind of bouncing through this talk, and what level were we going to give the talk, and some folks are like, man, we should totally show some code over here and how to go build the payload that goes along with this. Listen, I'm just going to go ahead and tell you, like, I want to demonstrate this technique, and sometimes, again, you may not need the full the full code execution piece to show the vulnerability. You can cause an app to crash with this very easily, without writing the code in this, right? What do you use for a payload, though? Look, your payload goes into DLL main. You can get one of those out of MSF Venom and Metasploit. Obviously, that's going to get caught immediately by any virus, but hey, whatever. Or write your own payload, right? When it comes down to it, this isn't about the payload. This is about getting the payload into memory and executing it in the first place, right? As far as custom payloads, in many cases, I'll tell you, most cases for me, I go inject into another process, right? And the reason I'm doing that is just for your own notification. The reason I always will inject into a remote process is that if the process I gained execution with dies or is killed by the user, in many cases I'm not privesking with this. I'm maintaining persistence with the user. Let's say it's with WebEx, and they click to close WebEx. Well, I'm toast, right? I want to make sure that I can inject somewhere else, and Explorer, their desktop, is a great place to do that, right? Because when they log off, I'm going to lose that context anyway. But Explorer, the desktop, is there until they log off. So I'm all about the survivability, right? So RSA is a big thing. Where we're like, hey, got to show how to apply this, right? So how do you apply what you've learned today? Well, I have 2 apply it slides, right? Because this talk really speaks to, I hope, both red teamers and blue teamers, right? If you're a red teamer, I hope that you've either learned something today or reinforced some ideas around how to gain that persistence and beat the blue team at their game, right? I'll tell you, a lot of the blue teamers are looking for auto runs, and they're looking using that frequency of least occurrence, right? And saying, hey, where are my deviations from baseline, right? Where do I have something extra? This is a way to beat that, right? So from a red team standpoint, what do you want to do? You want to go examine the software loaded on your organization's golden images, and you want to go look for software that starts with elevated privileges. I prefer digitally signed in case whitelisting controls are in place, right? So that generally, wins me or gives me a little bit of extra AV heuristic bypass as well. I'm a big fan of that. And then I want to determine if the software packages allow for unprivileged users to add files to the directory. Look, if they can, it's a great candidate for privilege escalation. Otherwise, it's just good for whitelist bypass. One thing that I want to throw out here as we talk about this is the difference between looking at auto runs on the system versus the auto runs for the user that you just exploited, right? And I'll tell you that from a privilege escalation side, I want to be on the system, right? But from just a persistence side, I generally want to be on the user, right? So again, if I've got privilege escalation, I've got that plus persistence, right? But But again, in the cases where I don't have that, I want to make sure that I take a look at the user's auto runs as well. These are going to be stored in the user's ntuser.dathive, and at runtime, like let's say you just fished onto a box, you're going to be looking at the HKey current user hive as you do your queries, right? Okay, let's come back to Blue Team, right? Because I'm going to tell you, I've been on both sides of the keyboard, right? Most folks know my bio here. I've definitely been on the offensive side, and today I do more incident response than anything else, right? And so Blue Team and defensive security practitioners, let me go ahead and tell you, this is hard to detect. It's hard to detect, and it's hard to defend against, right? I'll tell you that follow the red team slides and go out and assess. I mean, if the red team's doing the right job and they're reporting well to you in the first place, this stuff is getting identified and it's getting fixed. Well, let's assume for a minute it's not, right? Because you can't just say, hey, the red team's got it. Cool, we're good. Ugh, what does that even mean, right? And so engage the red team to do it with you, right? One, you're going to learn a lot. And two, you can make sure and kind of audit the work there, right? Because particularly if there's other low-hanging fruit, right? This is a spot where I want to use the red team collaboratively. I want to examine my tooling. Can I detect an abnormal DLL loaded into a legitimate process? Because I'm going to tell you a lot of them can't. A lot of your tools can't. Now, I'll tell you that there's a great tool from SysInternals now owned by Microsoft called DLL List, right? And it can look for DLLs and tell you whether or not they're digitally signed, show you the full path for those DLLs, and start looking for those outliers. Determine whether all signed binaries should be allowed to load per application whitelisting rules, right? In most cases, the answer to this is no. But hey, I mean, this is another big one for you. If you're implementing whitelisting in the first place, what does that look like? And then finally, want to examine EDR capabilities and determine if the rules can be structured to detect abnormal DLL loads. I'm going to tell you this is a very heavy lift, right? Because it's one thing to say we baseline the application, but I use Microsoft Word as my example of this. Did you know that Microsoft Word can actually go in and play embedded videos? There's a whole browser embedded inside of Word. I mean, like you look at these extra features, you're like, who precisely needed this, right? And the answer is, well, I don't want to say nobody. Clearly, somebody at some time did. The problem is I baseline Word when none of that stuff is running, and I get an entirely different runtime profile than when somebody sends me a document with these weird embedded videos in it. And anyway, the bottom line there is that it's very, very difficult to do this, right? So just bear in mind there that that's a thing. I'm more about hunt for my DLLs in the first place. I want to close my thoughts here or give a couple closing thoughts and say, proxy DLLs have been used as their persistence method in advanced attacks for years. We're having a big OST tooling debate, offensive security tool debate, in the public right now about, hey, should we be talking about this stuff, for an offensive side or not? Are we giving something to the attackers? My friends, let me tell you, we're not giving anything to the attackers here, right? I've seen several different nation states using this. At least I would say all of the big players, all of the names we know, and there's no reason to tick off another government again by mentioning those names. But game on, we'll just go ahead and say that. I'll say that because tooling is getting better, we're likely to see an increase in this technique. I talked about how easy it is to see auto runs, and EDR is changing the game on that, right? Your EDR can probably show you very quickly the outliers, something that took manual analysis, a while back, right? And so I expect attackers to continue to use this more. We're seeing it, I would say, not with great frequency in our incident response, but not with no frequency either. And then I'll finally mention here that if you haven't seen these yet, I don't want to tell you it's because you're blind to it, but it's probably because the attackers are able to maintain persistence using easier methods. We have worked repeated incidents where attackers have navigated these business-to-business links, B2B VPNs, and we see changes in the attacker profile between different organizations they compromise this way based on what your security profile looks like. They won't expose their top-tier tools unless they have to. So what I'm going to throw out here and say is if you're sitting here poo-pooing this as a blue teamer and saying, ugh, never seen that before, I just want to close here and say, my friends, maybe there's a reason. Thank you so much for your time. Thank you for all the sponsors, for RSA, APAC, and thanks to RSA for having me. It's been a great time. Thanks, folks.